So the question is appearing properly. Comments పెట్టేసి which is your class. Okay, it is visible. The questions are visible for you. Right, come on. So a mathematical expression a mathematical expression
వేరే పేరు చెప్తుంది సార్.
Now see the question. First question is the following bilateral element. The following constitute a bilateral element. What are the bilateral elements? A resistor, FET, vacuum tube, metal rectifier. What is the answer for this? So, bilateral element is a resistor. Bilateral element is a resistor. Yes, ma, all of you. So, what would be the next question? The current I is equal to Q by T, dQ by dt, d square by dt square, Q. So the answer is dQ by dt. Answer is dQ by dt. Next. See here, in a resistor R, the power P is equal to I square R. Power P is equal to I square R. Okay. Next. What is the next one? The voltage V across the inductor L carries a current of. The voltage across inductor L carries a current I is equal to. So what is that? V is equal to L into di by dt. V is equal to L into di by dt. Voltage across the inductor is V is equal to L into di by dt. Next. The energy stored in inductor is, the W energy stored in inductor is half Li square. Half Li square. Half Li square, Li square, Li di by dt, Li. Half Li square is the answer. Is it or not? Next. Two resistors are connected in parallel and each dissipate 40 watts. The total power supplied by the source equal to. Two resistances are connected in parallel and each dissipate 40 watts. The total power is P1 plus P2, 80 watts. The total is 80 watts. What is the answer for this? 80 watts is the answer. Next. See here the problem. The current I1, I2 are given circuits are 2 amperes, 20 ohms and 30 ohms. What are the currents? What you can have? I think current through I1 is higher than I2. Current through I1 is greater than I2. Option A is not the answer, option B is not the answer. So 2 into 30 by 50, current divider formula. 60 by 50, 1.2. 1.2 and 0.8. 1.2 and 0.8 is the right answer. So this will be the answer. Current division. What is this one? Current division. Next. Do this problem. 12 volts you applied, 4 farads are here, 2 farads are here. What is the voltage across this one? What is the voltage? 4 volts, 8 volts, 8 volts, 4 volts, 6 volts each, 0 and 12 volts each. So, in the case of capacitors, opposite combination we have to take. 12 into 2 by 6. 12 into 2 by 6. 24 by 6. 24 by 6. What is that? One is having 4 volts. One is having 4 volts. One more is 12 into opposite resistance. 4 divided by 6. 48 divided by 6. So 8 is the answer. What is that? 4 volts and 8 volts is the answer. This is a opposite combination for the resistive circuit. Opposite combination for the resistive circuit. Next. What is the other one? The equivalent capacitance. The equivalent capacitance for the given circuit. The equivalent capacitance at these two are is in series. These two are is in series. 2 into 2 by 2 plus 2. 1 farad. 1 farad in parallel with 1 farad. 1 plus 1, 2 farads. 2 farads is the right answer. Which is the opposite combination to the. Are you okay, ma? 2 farads is the right answer. Next to the equivalent inductance of the circuit at terminals A and B. These two are is in series, which becomes 8 farads. 8 farads in parallel with 8 farads. 4 farads you are going to get. Option A is the right answer. Option A is the right answer. Okay, ma? Right? Next. See here. What is that? 2 inductors L1 and L2 are connected in parallel. The combined inductance is, they are connected in parallel. Combined inductance is L1 into L2 by L1 plus L2, which is like a resistors. L1 into L2 by L1 plus L2. Next question. If two capacitors are connected in series, the combined capacitance is C1 into C2 by C1 plus C2. C1 into C2 by C1 plus C2. C1 into C2 by C1 plus C2. Next. See here. The impedance Z1 is equal to 10 at an angle of 30. Z2 is equal to 20 at an angle of 50. Then Z1 into Z2 is, what is Z1 into Z2? 10 into 20 at an angle of 30 plus 50. How much it becomes like? 200 at an angle of 80 degrees. Where is this answer? 200, because 10 multiplication of angles means we have to add 30 plus 50, which becomes like a 80. That is the answer. Next. What is the next question? The next question is, see here. The impedance Z1 is equal to 20 at an angle of 50. Z2 is equal to 10 at an angle of 30. What happens now? Z1 by Z2 is what? Z1 by Z2. 20 divided by 10, 2 at an angle of 50. When it comes to the top, it becomes minus 30. That becomes like 2 at an angle of 20 degrees. 2 at an angle of 20. Where is that answer? Answer is D. Answer is D is the answer. 2 at an angle of 20. Okay? Right. Next question. See here. What is that? It is given that Z1 is equal to 2 plus J3. Z2 is equal to 6 plus J3. They are in ohms actually. They should be in ohms. All should be in ohms. Z1 plus Z2. 8 plus J6. 8 plus J6. 8 plus J6 means what? Square root of 8 square plus 6 square. How much it becomes like? Root 100. That is equal to 10. That is equal to 10. So answer is 10 watts. 10 ohms, not watts actually. All are is in ohms. They should be in ohms. Okay, ma? Clear all of you? What is the answer for this? Yeah. Srihari? Santosh Shahu, right, all of you? The load resistance needed to extract maximum power from the circuit figure dash ohms. So if you want to get the maximum power means the load resistance must be equal to internal resistance. The load resistance RL must be equal to internal resistance. What would be the load resistance? RL. What should be the internal resistance? You can make short circuit like this. How these two are is in? They are is in parallel. 6 into 3 by 6 plus 3. 18 by 9. That is equal to 2 ohms. Your load resistance also should be equal to 2 ohms. Internal resistance of this combination is 2 ohms. 6 in parallel with 3 ohms. When we are looking from this point, that becomes like a 2 ohms. Hence answer should be 2 ohms. Answer is A. Everybody's understood this one? Clear all of you? So not yet, I don't know ma, actually the sub-engineer exam is postponement. We have to see within a 1 or 2 days it will come out if anything is there. See here, the Norton's equivalent circuit for the network shown in figure between A and B. Norton's equivalent we have to find. Norton's equivalent means what we have to do? Screen. What is the Norton's equivalent? Anybody? I am waiting for your answer. See the question. We want to find the Norton's equivalent. The Norton's equivalent means we have to make the short circuit like this. Once if you are shorted, this one also becomes short circuit. When it is short circuit, what is the voltage? 18 volts divided by 6 ohms. ISC, short circuited current, is equal to 18 volts divided by 6 ohms, which is 3 amperes. So this answer is wrong, this answer is wrong. Either this one or this one we have to see. When you want to calculate the Norton's equivalent, you must looking from this terminal and the voltage source should be make 0 and current is driving from this point. Whenever current is driving from this point means these two are is in parallel. 6 in parallel with 3. 6 into 3 by 6 plus 3, it becomes like a 2 ohms. How much it becomes like 2 ohms. So I hope answer is D. I given some time to answer yourself. Are you okay ma? 3 amperes, 2 ohms. Norton's equivalent. Norton's equivalent. Next. Find the current flowing through the 9 ohm resistor. Find the current passes through 9 ohm resistor. So what is the current passes through 9 ohm resistor? Tell me. What is the current passes through 9 ohm resistor? You can apply superposition theorem. Or you can apply nodal analysis. You can apply the nodal analysis. Something like that. You have the current here. What is that? I can say V is here. V minus 3 divided by 6 plus V by 9 is equal to 2 amperes. Minus 2 is equal to 0 is equal to 2 amperes. What this becomes like? V by 6 plus V by 9 is equal to 3 minus 1 by 2 plus 1 by 2 plus 1 by 2. What this becomes as? V by 6 plus V by 9. V by 6 plus V by 9 is equal to, what is this one? 7 by 2. 7 by 2. Take an LCM. Take an LCM. You take LCM as 18. You take LCM as 18. What this becomes like? 3 plus 2. 5V. 5V here. So how much it is? How much it is? 7 by 2. This is 6 plus 1. 7 by 2. So V is equal to 7 into 18 divided by 2 into 5. 2 into 5. What happened this one? So this is 10. How much you are going to get? 1 ampere you got? Or otherwise, how can you do this procedure? How can you solve this one? We can do by some other procedure also. Have you got it, ma? So if you apply 3 volts here, when 2 amperes is applied, what happens? 2 into current divider formula, 2 into 6 divided by 15, 12 divided by 15. This is due to this current source. When this voltage is makes 0 and apply this voltage source, make this current is 0. How much? 3 divided by 15. 3 divided by 15 is the current passes here. So 3 divided by 15 plus 12 divided by 15. So 15 divided by 15 is equal to 1 ampere. Answer is 1 ampere. Based on the superposition. Based on the superposition, how much you got? 1 ampere. Are you okay, ma? Right, all of you. Next. The superposition theorem is used when the circuit contains a single voltage source, a number of voltage sources, a passive elements only, none of this. What would be the answer for this? Superposition theorem is applied. Yeah, if the network has a number of voltage sources, multiple sources are there, then only we can go for superposition theorem. Multiple voltage sources, we can go for superposition theorem. Next, under the condition of maximum power transfer, what would be the efficiency? the efficiency according to the maximum power condition is 50%. Yeah. While calculating R Thevenin, the Thevenins are Norton's equivalent. All independent sources are made dead. All voltage sources are made dead. All current sources are made dead. All voltage and current sources are dead. Totally, all voltages and current sources are made dead. Independent sources. We have to make all independent sources make dead. All independent sources. Okay, ma? Right? No. A and B are not same meaning. A and B are not same meaning. Actually, what happens is, you are not making the dependent sources are zero. All independent sources we make zero. The dependent sources, for example, if you have a source like this, dependent sources cannot make zero. Only independent source makes zero. All voltage and current sources zero means both dependent and independent sources. Video is not coming here. Okay, ma? Now it is visible. Okay, ma? Right? In the circuit shown in figure, R is equal to 20 ohms. This R value is 20 ohms. The current I is 20 amperes. This current I is 20 amperes. When R value is 10 ohms, this R value is 10 ohms, the current I would be, actually in this question it should be 2 amperes, not 20 amperes. In the question it should be 2 amperes. Then what is the current after when R is equal to 10 ohms? R is equal to 10 ohms, what is the current? Suppose R is equal to 10 ohms, what is the current? 1 ampere, 2 amperes, 1.5 amperes, 3 amperes. Anybody can give the answer for this? The answer is 2 amperes only, because here is current is 4 amperes. When it is at 20 ohms, 4 amperes. When it is at 10 ohms, 4 amperes. Current through the current in series with the resistance, ideal current in series with resistance, resistance doesn't show any effect. Answer is 2 amperes. For example, when you have a current source like this, suppose this current is 10 amperes, whenever resistance is 10 ohms. If the resistance is 20 ohms, what would be the current here? Current is 10 amperes only. Current is 10 amperes only. So, there is no effect of series resistance on a current source. That's why answer is 2 amperes. Answer is 2 amperes. Next, the linear circuit, the superposition theorem can be applicable to calculate voltage and power, voltage and current, current and power, voltage, current and power. Tell me, it's a very good question, important question. So what is the answer, ma? Superposition theorem principle can be applied to calculate only voltage and current, not for the power. Answer B. Superposition theorem is not applicable to determine the power in a circuit. So many students are answering D is the answer, but it is wrong. Superposition theorem is not valid to determine the power in a circuit. No, please check it. Power cannot be calculated by using superposition theorem. That's why current and voltage only can be calculated. This is a very, very important question. The power cannot be calculated by using superposition theorem, which is more important. Which of the following theorems are applicable to both linear and non-linear? Which of the following theorems are applicable to both linear and non-linear? Can you give the answer for this? Anybody? So, none of the above is the answer. None of the above is the answer. Why? Because superposition theorem is linear. Thevenin's theorem is linear. Norton's theorem is linear. Non-linear means Telegon's theorem. The answer should be a Telegon's theorem. Telegon's theorem. This is the important one. Telegon's theorem can be applied for both linear and non-linear. Here that option is not available. Yes, Venkat Gowda, right. But now as per the answer is concerned, none of this is the right answer. Next. The power factor at resonance of a RLC series circuit is correct answer is Telegon's theorem. I told you na. Okay ma? Yes, it is a very simple question. That's why I am waiting for your answer. Unity. Power factor is unity. 1. Power factor is 1. Next. The power factor at resonance in parallel RLC circuit. In parallel RLC circuit is, for parallel RLC circuit is also unity power factor. Who answered 0.8? SBN. What are you giving answer here? 0.8 leading is the power factor at resonance. Either for series resonance or parallel resonance, the power factor is unity. The power factor is unity. Not 0. For both series and parallel resonance, the power factor is unity only. The power factor is unity only. Because the net reactance is 0, net susceptance is 0. There is no imaginary component in a series and parallel resonance. Right. In a RLC series circuit, at the resonance frequency, the current is maximum, current is minimum, impedance is maximum, voltage is maximum. What is the right answer? So, we know very well the current is maximum because Z is equal to R, current I is equal to V by R. Z is equal to R, current I is equal to V by R. Maximum current. Next. In a series circuit at resonance, the following occurs. V is equal to VR, XL is equal to XC, Z is equal to R. All the conditions are satisfied. All the above is the right answer. Let series resonance. Right? Next question. In series resonant circuit, the impedance of the circuit is minimum, maximum, 0, none of this. In series resonant circuit, the impedance is minimum because Z is equal to R. Z is equal to R. What is the impedance at parallel resonant circuit? The impedance at parallel resonant circuit is maximum, which is given by L by CR. For parallel resonant circuit, the impedance is maximum, which is given by L by CR. For this answer is this one. This is also a important question. That's why I told you. Yeah. The quality factor of RL circuit is given by omega L by R, omega naught L by R. The quality factor Q is equal to omega naught L by R. Okay, ma? This is what the questions available in this schedule. First one. No, imagine.